Hey guys, it's Love Gupta here, and so I'm here to present my final project, which is about Spark streaming. So basically, Spark streaming is like a stream processing extension of the core Spark API. It provides a wonderful framework for processing live data, which is highly scalable, which can be scaled to hundreds of nodes, has very high throughput since it uses the Spark engine where a lot of stuff is cached into the memory. It's highly fault tolerant because of the concept of RDDs. And the best thing is like Spark Streaming has very nice integration with real-time data sources, such as basic sources like file systems, characters, or you can even further like advanced sources like Kafka and Twitter. And it's easy to create custom receivers as well. So in the nutshell, it's a layer on top of Spark where data streams can be transformed and batched in a sequence of very small RDDs. And so I think it makes sense to first discuss what Spark is. So Spark is an open source low latency cluster computing system, and Spark is really performant because of the fact that it holds intermediate results in memory rather than writing them to disk. And the thing is like, so if you have chain a lot of MapReduce programs, they all write to the HDFS, and then Spark doesn't have that kind of overload, and that's why it can run programs up to 100 times faster than Hadoop. And all of this is possible because of the memory abstraction they have called RDDs, a resilient distributed data set. These are immutable collection of objects which can be stored in memory or disk. And you can only apply parallel functional transformations on these objects. You cannot do like fine grained updates. And because of this, you can only have like a whole lineage of transformations on the same data set, so that whenever there's a failure, you can always go back to the consistent data set and perform those transformations. And that's why it's so fault tolerant. Now, looking at Spark streaming, the main concept is about D streams. D streams are basically sequence of very small RDDs. These are very small deterministic batches. And these small batches can be as small as half a second with a latency of about 1 second. And so the way Spark streaming does it, like all these small batches are still RDDs and Spark engine processes the data. So DStream is nothing but just a sequence of all the small RDDs. And now you can have multiple transformations on these RDDs. You can have the standard RDD operations. You can have window operations, a little bit more advanced. You can also do a lot of join operations where you can join two D streams, or you can even join D stream with an RDD, since D stream is already an RDD. You can also apply machine learning algorithms using MLib. And so this data, Spark streaming can also output to various output sources like file systems, databases, and dashboards. Now let me talk about my project. So my project is about revealing trends and patterns across demographics from live Twitter data stream. And not only that, recently I've seen there's a huge surge of spams. So also one more problem that I'm trying to solve is filtering through spam messages to get relevant trending information. And so the main motives are like subscribing to a real-time Twitter feed, transform the Twitter feed to extract most relevant fields from the huge tweet blob, process the primitive fields to provide more value, and then detect possible spam messages. And after that, I'm just sending the data to Elasticsearch to make it more indexable. And then using that index data, I'm creating analytical dashboards. And this is so basically the programmatic workflow. So first I connect to the Twitter streaming API. Then I create a streaming context, basically these streams with the batch interval of 10 seconds each. Then I extract important fields and produce a JSON out of there. And now with this JSON, I have a spam detector function which kind of flags the spam messages. And then I convert this JSON into a map and send it to Elasticsearch cluster. And finally, on the Elasticsearch cluster, I have Kibana dashboards running on them. And so this is exactly how a sample tweet blog looks. It looks like this is a JSON with so many fields and a lot of garbage value. And that's the whole purpose, like making sense out of this garbaged out Twitter blob. And so the implementation, I have created two EC2 instances where one instance is is supposed to run Spark streaming job, and the other instance is supposed to run Elasticsearch and Kibana. I've also modified the security groups to allow internal traffic among them. So install Elasticsearch, install Kibana. I had to create a new application to generate authorization keys for Twitter API, and then installing the SPD tool since my code is in Scala, and then I'm adding the dependencies to the SPD tool, and that takes care of everything. So so just a little bit of code walkthrough. So this is the initial section of my code where I first extract credentials from the config file and then pass them to the Twitter 4J API. So here you can see, and each credential is supposed to have 4 keys, and then each of those keys is passed to the Twitter 4J API, which allows me to connect to real-time Twitter trending data. Then so this is now comes the main part, the main entry point for all Spark streaming functionality. I define a streaming context where I tell them that the batch interval needs to be 10 seconds each. And you can also see I'm also defining my Elasticsearch indexes, like what's my index and index type of my Elasticsearch and where is it located, what's the address for the Elasticsearch. And then so this value stream I'm calling Twitter utils, and this creates a stream of all the tweets for stream and with the filters I had passed. Now this is the major crux of the code, where what I do is for each stream I map all the individual tweets, and for each tweet what I'm trying to do, basically to explain, all this Twitter API sends us all these objects called status, and what you have to do is extract all those things from the blob using status. So now I extract user ID, description, screen name, followers count, that's primitive fields, but something like user followers ratio is something that I calculate. And so this is like something where I tell me what is the ratio of number of people who are following you divided by the people who you follow. And this is important in filtering out spam bots because they follow a lot of people, but not a lot of people are following them. Other than that, then I also get some geo information, the language information, and then I get the tweet itself, and then I also extract hashtags from the text, and there's some location information other than that. Now once I'm done with that, then I have this spam detection logic which I have kind of inherited from data sift. And so what they have used is like, so generally you flag recently created users because it's like that those are very commonly spam bots. Then you flag users that create little content because they're not of much value. Then you flag users with few followers, basically with low followers ratio. Then you flag users with short description. You flag messages with large number of hashtags. You flag messages with short content length. And you want to flag messages which are requesting for retweets and follows. So I kind of search for all these combinations of RT and follow, and I kind of remove the messages that have them. And so this is exactly the implementation of my spam detection. So this is a very linear model where each of the line represents one filter, and basically it's just a Boolean and over all the booleans. And at the end, if a tweet passes through all these filters with a true, then it's not a spam. And if it passes through and it gets stuck to any of the filter, then it is a spam. Then I just relay this data to Elasticsearch to, if you remember, this is the exact same index and node that I had defined in the configuration initially. And so this is how I execute my code. Now it's time for some real demo. So this is basically, I had run this code from my Elasticsearch instance, and this is like, so every 10 seconds it is sending that tweet were extracted. And now, so now this is the tool for Elasticsearch head where I can see content from my Elasticsearch. So I can see the index to which I send my data. It has about sizes of 2.65 GB with about 3,331,000 tweets. And I can even go and look into the data. So I can select my index, and based on index, I can see what the tweets are. And if I look into them, now if you see, like, from the huge tweet blog which wasn't making much of sense, now we have a much more clearer vision into those tweets, which only useful information coming out of them. And now once we are done with Elasticsearch, we can create a really interactive Kibana dashboard. So now this Kibana dashboard is being refreshed every 10 seconds and has data for the last 1 hour. Now right now, let's say I've added some filters, but let's first remove them. So what I have here is I have total tweets over time, and it's like per minute I'm receiving about 1,000 of them. And this is top tweets over time. So in this, these are color coded. You can see which are the top tweets that are trending for that particular minute or hour. And then you have a filter for if it is a spam, true or false, like a quantity of tweets which are spam. And so you can see, actually, according to my rule, there are about 40.79% of the tweets which are spam. Then I also have top hashtags by language. So you can see Japanese, English, Russian, and then I have a distribution of tweets by languages as well. And then I have top tweets overall. I also have some reporting around location, but what I've realized, like 90% of the times, we do not get place countries, so the data isn't that interesting. But so what I'm trying to show is the ability, like I can still do like top hashtags by country. And now the stuff gets interesting, because now if you see on a separate note that what are the trending data right now on Twitter, you can see these are the trends that are there. But if you see, if you match them, you don't see them. But as soon as you start filtering, let's say you want to filter that you only want documents which are not spam. So I just created a filter, and you can see. So now this is all the data for non-spam data. And let's say I also filtered them based on language. Yeah, so now you can start comparing that. No Control Campaign PH is there in my list. Gender Swap Movie, which is the trending one, is there in my list. And so now you can see, now I have made my top hashtags much more relevant, much more realistic from what we had before. And this dashboard is pretty interactive in a sense that if I really want to understand something, I can just add a filter. Like right now, let's say if I want to understand what are the other hashtags that came with the tweet for gender swap movies. So when I click on this, it will get created as a filter. Yes. And now based on that, you can see what are the other top hashtags with respect to it. So it's like that. And anytime you can see what are the total number of tweets we have. And so this is what I have for now, and that's with this I would like to conclude my demo. And I have some and I would like to end with the lessons learned. So lesson learned is Spark Streaming is pretty powerful technology. Like with a small project like this, I was able to create something really interesting. And the good thing is the code is reusable for batch as well as stream processing. Right now, I have very small batches, but if I make my batches longer, then it can be used for batch processing as well. And I feel like it might just be able to completely replace Hadoop MapReduce jobs because of the performance and fault tolerance. Next thing, I also learned that Scala is a pretty powerful language. So even such a complex application, I could just create this application in less than 150 lines of code, which is pretty sweet. And especially if you use tools like SBT and IntelliJ, then it goes really bonkers. And then some future work, it would be like combining real estate data with NLP, natural language processing data, to get sentiment analysis. Or I would also like to join the data stream with machine MLib library to enhance spam detection. So that's all. Thank you.